Have you ever used a program that just crashed on you? Or maybe one that gave you a really weird, unexpected result? Well, in this explainer, we're going to get into exactly why that happens and, more importantly, how we as programmers can stop it. We're diving into a really crucial topic for your OCR GCSE Computer Science course, producing robust programs. This is the secret that turns a simple bit of code into professional, real-world software. Ready to see how it's done?
So we all know the basic model, right? A program takes an input, it does some processing, and it gives an output. Simple enough. But that whole idea rests on one massive assumption, that the input is always going to be perfect. And this leads us to the big question that this whole topic is built around. What happens if a program's input is not what the programmer expected?
You know, when you're programming, it's so easy to think that everyone will use your program exactly the way you designed it. You ask for a number, you get a number. You write instructions, you assume people will follow them. But let's be real for a second, that's just not how the world works, is it? Users get distracted, they make typos, they try things you would never have even imagined. They aren't perfect test cases, they're people.
So how on earth do we close this gap between our nice, clean code and the messy reality of how people actually use it? Well, the answer is exactly what we're here to talk about. The robust program. This is the professional solution for building software that can handle pretty much anything the real world can throw at it.
Okay, so what exactly is a robust program? In short, it's a program that's built to expect the unexpected. It's designed to handle all kinds of strange or incorrect input without just falling over and crashing. The whole point is to create software that just keeps on working, no matter what. It's built for real situations and for real people.
And why is this so important? Well, because a program that isn't robust is basically just waiting to fail. It might crash completely, it might spit out the wrong answer, or it might just start behaving in a completely unpredictable way. Think about your online banking app. What if it showed you the wrong balance just because of a small typo? That's not just a minor bug, that's a serious problem. So here's the key thing for your exam. Robustness isn't about fixing things after they break, it's about designing your program to prevent those failures from ever happening in the first place.
All right, so we know what robust programs are, but how do we actually build them? Well, it's not guesswork. There's a specific method for it, and it's called defensive design. This is how you create software that's tough enough to survive out in the wild.
Defensive design is really a way of thinking. It's the practice of writing code with the core assumption that mistakes are going to happen. The goal is to anticipate those mistakes and build in protections against bad input. It's a proactive approach. You're trying to stop misuse and errors before they even have a chance to cause a problem.
So, what kind of mistakes are we talking about? Well, a program could fail if a user types in text when it's waiting for a number. Or maybe they enter a value that's way too big or too small, something outside the valid range. It could even be something as simple as using a different date format, like using hyphens instead of slashes. And of course, sometimes people just plain ignore the instructions. A robust program is designed to handle all of this.
Okay, let's make this really concrete. Imagine a simple program that asks for a number between 1 and 100. Now, what could go wrong if a user decides to type in the word hello, or a negative number like -5, or a number that's way out of range like 1,000? If that program hasn't been designed defensively, any one of those inputs could cause it to crash.
Now, this is a really important distinction, and it's the kind of thing that comes up a lot in Paper 2 questions. A non-robust program, well, it just trusts the user. It assumes the input will be correct and tries to process whatever it's given. A robust program, on the other hand, is a bit more careful. It checks the input first to make sure it's valid before it tries to do anything with it, and that one simple check makes all the difference.
Right then, let's put all of this together and really focus on what you need for your assessment. We're going to look at the specific language that will help you get those top marks, and then we'll summarize the key points from everything we've covered.
When you're writing about robustness in your exam, using the right language is absolutely key. Instead of saying something vague like, "it makes the program work better," you need to be specific. Use phrases like, "it handles unexpected input," or "it prevents the program from crashing," or "it protects against incorrect data." Using this kind of precise language shows the examiner you really know what you're talking about.
So, to wrap it all up, number 1, robust programs are built to cope with real, unpredictable users. 2, the way we do this with defensive design, which means programming with the expectation that mistakes will happen. 3, a lack of robustness is what leads directly to crashes or incorrect output. And finally, and this is the most important point of all, this topic is all about the prevention of errors, not about repairing them after they happen. That is the heart of building robust programs.